Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, salatu wassalam ala rasulillah wa ala alihi wa ashabi ajmain amma ba'd. Students, in this video we are going to start the second part of parallelogram. In the first part of the parallelogram we studied in a parallelogram what are the properties are there, the main characteristic of parallelograms. So with the basic universal factor of a parallelogram, both opposite sides are parallel. With the data we can have another 4 properties of parallelogram. Okay, we studied that on parallelogram 1. So the parallelogram 2 is basically you are going to prove a given quadrilateral. If a quadrilateral is given, with the data we are going to prove how the quadrilateral become a parallelogram. So in this lesson we are going to discuss the conditions that need to be satisfied. The conditions or the characteristic need to be in a quadrilateral, so the quadrilateral became a parallelogram. So like the properties of four of the properties of parallelogram what we studied, individually like the 4 individually we are going to apply another 4. Okay, when we start the first theorem, you are looking at the first theorem, you can easily understand how it going to be. So it's like the congruence of triangle. If 2 triangles are given, so you are going to check under which rule. You have 4 rules for the congruency, so you are going to check with the data. With 3 data you are going to check, and you can select out of 4 which rule can be a triangle going to be congruent. Like that you have 4 theorems with the given quadrilateral. If you check the theories one by one, you have 4. If you check the theorem one by one, so you can prove that given quadrilateral is a parallelogram. Okay, let's go to the first theorem so you can easily take the conditions. Okay, the first theorem is the first property what we studied. Okay, what is the first property what we studied on parallelogram 1? The first property is opposite sides of the parallelogram are equal. Okay, in reverse we are going to say if the opposite sides of a quadrilateral are equal. Okay, we know how to get in reverse. The parallel lines are given, a transversal is intersecting. You have 3 types of angle. So in reverse, if you have the one of the 3 types of angle, you can prove those straight lines are parallel. Likewise, if the opposite sides of a quadrilateral are equal, then we can prove it is a parallelogram. Basically, if the opposite sides of a quadrilateral are equal, then all the characteristic, all 5, we are studying 5 characteristic, all 5 characteristic can be within inside that quadrilateral. If the opposite sides are equal, so we can check. If we check the opposite angles going to be equal, we can prove it. The diagonals bisect each other, we can prove it. Diagonal bisect the area of the quadrilateral, and opposite sides are parallel, so we can prove other 4 properties. So when we have one of the property, the others are coming together. So all 5 characteristics are coming together with the first one, so we can have the particular quadrilateral with opposite sides are equal, so it's became a parallelogram. Okay, we'll check how it's going to be applied. So we have given a quadrilateral PQRS. So the data in the figure of the quadrilateral PQRS is one of the opposite sides. We have two pairs. One of the opposite sides are equal. PQ and SR are equal. So what about the PS side and what about the QR side? So without the other side. So opposite sides of a quadrilateral means both pairs. Okay. So here we have only one pair. So we can't continuing the other four. We can't prove the other four of the characteristic of parallelogram. So we can't say PQRS is a parallelogram. We doesn't have any data. So we have only one pair. With this theorem, we can't use this theorem, the first theorem to the first figure, because we have only one side, one pair of side. So it's not a parallelogram. Okay, let's check the second figure. If we go to the second figure, the ABCD is a quadrilateral. The opposite sides AB is equals to CD and AD is equals to BC. So the theory, the data of the theory is on the second figure. Opposite sides of a quadrilateral are equal. So we know if we draw opposite sides are equal in the parallelogram one we discussed, it should be the opposite sides are parallel. It became the opposite sides are parallel. Okay, so we can have continually have the other four. So if the opposite, only this data is enough to prove the parallelogram, not considering the other four. If we have the opposite sides are equal, others are automatically there. So that's why we called as the parallelogram. Yes, ABCD is a parallelogram because the opposite sides are equal. Okay, let's take the third figure. It's KLMN. The quadrilateral is KLMN. The data of the opposite sides are equal. Both opposite sides are 4 centimeter and these sides are 3 centimeters. So it is also a parallelogram. It can be a parallelogram. We can prove the other 4 also. So KLMN is a parallelogram. Okay. What about the fourth figure? So let's take the fourth figure. So we have all the sides are equal. So here in the quadrilateral ABCD given, the data is all the sides are equal. Right? All the sides are equal means, in other words, we can say opposite sides are equal here. All the sides are equal. We can name this quadrilateral as a square, because if all sides are equal, the quadrilateral is a square. Yeah. So, but the opposite side also equal here. So we can say the opposite sides are equal here. So ABCD is a parallelogram. So don't confuse. Square is a parallelogram. We'll study it in the last part of this parallelogram too. Yes, square is a parallelogram. Okay, because the opposite sides are equal. Okay, so the first theorem, this is how we are going to prove. We are going to check the data and we are going to prove whether a quadrilateral is a parallelogram or not. A quadrilateral can be a parallelogram by fulfilling this data, by satisfying this data. What is the data? Opposite sides are equal. There are two pairs. So all the both two pairs are going to be equal, not one. So if you check the figure 1, it consists only one pair of opposite sides. So not a parallelogram. The second, third, fourth, all the pairs. We have two pairs. All the pairs opposite sides are equal. So the second, third, fourth all are a parallelogram. Okay, right. Let's move on to the next part. We have, if we study the theorem, we have a formal proof to understand the theory. Okay, so we'll go for the formal proof.